we're here to talk about how Autodesk is introducing artificial intelligence into their water industry software. So some of the things that includes that's helpful to you as a water industry professional are going to be the predictive analysis, demand forecasting, automated condition assessment, machine learning, deluge. So we're going to talk about those. And then if we get time at the end and you all are interested, we'll also mention grading optimization. Now, that's not part of Autodesk Water Solutions, but grading is awfully close. I mean, they say drainage and grading. And so, you know, many of you that are interested in drainage are also interested in grading. So if we have time, we'll look at that. Okay. Okay, so this is to talk about predictive analysis and how is it used and why is it used. Okay, so the sample that they give is a city of San Francisco and talking about their public transportation system. So you input your historical traffic data in, weather conditions, special event information, and then the AI can predict when and where you're going to have traffic congestion in the city. And so you can do things like change lanes or, you know, put up barriers in certain places, et cetera, to direct the traffic correctly. Okay, here's an example. They talk about how it would allow the city to adjust their bus and train schedules in real time. Okay, so if they find that a whole bunch of people are coming in because the Dodgers are going to be in town against the Giants, then they can adjust their BART schedules accordingly. And that's supposed to be a picture of BART there, but as you see, it's not. Okay, so predictive analysis, again here, they're saying that if you can predict this crush is coming, that lets you send more trains, alleviating or eliminating the possibility of the crush. You send the trains, you take care of it. The problem never actually arises. Okay, then we talk about demand forecasting. So this is similar, but this is an example here, say on the left where there's a big event on the boardwalk or on some street, some city street, part of the city. We also have apartments that have just gone up in another part of the city. Well, that's going to affect your sewage treatment plants, your storm drain handling, et cetera. And that's done with demand forecasting. So the system can send out information to the sewer treatment plant to turn on some pumps, for example. You talk about automated condition assessment. Now this is getting in where the AI can read directly from your sensors that you have out in the field. For example, this text I have up here talks about PA Vision Automated Pavement Condition Assessment System. Okay, and it uses a combination of cameras, GPS, LiDAR sensors. I'm not sure how the accelerometers would be used, and accelerometers, okay? And so this gives cities, counties, whoever owns pavement, the ability to see problems as they're developing before they have fully developed and caused conditions that where the road is no longer useful, et cetera. Okay. And this all ties in with the Autodesk software. Okay, so I go here. Okay, then we want to talk about machine learning deluge. This is the AI that has been put in info drainage software, which is Autodesk's drainage design software. now as part of their water systems, replacing some of the previous software they had, like sewer and storm and sanitary. That's what it was called, the old software. So anyway, what this does is it collects data, and this can come from monitoring sensors that you have in your system. It can also include your historical rainfall data, topo maps, soil composition data, and then it uses this as well as terrain to do flood prediction. Okay. As part of that, it does design optimization. As long as you have accurate flood maps, then you can use InfoWorks and info drainage. This is the data collection. You have topo map data, soils data. Okay. This is supposed to be representative of historical rainfall data. Okay. So it uses those data, and then it can figure where flood's going to happen, where's the deepest water, where's the river going to exceed the banks, etc. And of course, it can give reports, lots and lots of reports. Okay. Now, one of the biggest thing I think about the machine learning deluge tool is, I'm sure you've done simulations with water software before. Well, those can take dozens and dozens of minutes up to hours, overnight sort of stuff, right? The machine learning deluge tool, because it uses AI, it gathers your data and other data, historical data, into the equivalent of a large language model. That's not a true one-to-one, compared to actual language models, but it's like that, where it gathers these data and then it can reapply your changes basically instantly instead of waiting for another simulation to go through. That's part of info drainage. And here's an example here. They talk about, being able to, where water's coming from into our drainage, and then help determine where to put things like retention basins, swales. This is an example of a rain garden, green infrastructure. And info drainage, of course, supports green infrastructure fully. So instead of doing hard engineering where you try to put everything in through pavement, this uses green structure. It will do rain gardens, of course, retention ponds. You see filtration trenches and many other types of green infrastructure. Okay, I want to show some AutoCAD here, Civil 3D, and grading optimization. As long as we're talking about AI in Autodesk and really drainage related, is being able to design these sites. So what you do, if you look on your home tab, and this is in modern versions of Civil 3D, the most modern, 25, 24, when you install the software, it automatically has grading optimization installed. It's not a separate tool that you go get from Autodesk.com or whichever, right? So if I go here to analyze, on the far right end is grading optimization. So what you do is you add grading objects. Okay, so I'm going to add a building pad here. Come out like this. And I'm going to pretend this is a building. So I pick that feature line. We'll do each of these. Okay. And, you know, you can add, as you see here, ponds and retaining walls and curbs, etc. And then the grading optimization uses its AI to optimize the site for you based on, you know, am I looking for an earthwork balance, or am I looking for a certain amount to go out of the site, etc. I'm going to go ahead and just leave it like this. Now let's look at our building pad properties. Let's give a depth. Yeah, that looks good. Drain away, good. Okay. That we'll just take the defaults here. Soccer, baseball, and school. It got the names from the feature lines. So if once I've placed that, I've probably placed some drainage swales. Whoops. I got to place the polyline. Sorry about that. See, I decide I want drainage running down like this. When I do drain line, is it a break line? Sure. What color is it? White's fine. Okay. So let's go ahead and have it optimize. Pick your original ground surface. Okay, this one is a combination of the original ground as well as the existing road. Okay. Oops. Okay, so I want to check my preferences. This is your mesh quality, faster, medium, slower. Okay, that all looks good. Turn on the visualization toolbar. So this will show results in what you're seeing here. When I'm ready to go, I go down here, check the options. Okay, what's my minimum drain slope? Is going to be 2%. Let's do 1%. Where's my? And maximum drain slope. See if we can get by with 10. Any cut and fill constraints? No. This iteration is how many times does the AI look through the data and try to, you know, iterate it a little bit more, fix it towards our goals a little bit more. And this is where you can do the waiting for cut and balance or minimize total earth moved. Okay, so cut and balance is one thing, but if I have to move 1,000,000 yards from that side of the job to that side of the job, and hey, I balanced, well, that's a disadvantage, right? So you can set this. So let's go. I want to look for, see, this is letting me say how much cut or fill I want, or I can say I want to balance. Yeah, make that very important to me is what I'm doing. This is balance. This is how important balancing is. Trying to get them both at 100. Smooth the surface so that it doesn't have jagged edges. Let's go ahead and leave all that on. All right, okay. So we're ready to go. You say optimize. And it's kind of cool because you can watch it go. And you can see all the areas where the drain slopes aren't good enough. It's trying to make them better, of course. So it goes through. It's trying to use our rules that we gave it. And you can see it's adjusting all the triangles from that original ground surface that we provided. Now, if you don't like how long something's taking, you want to change it, etc., you can always just stop. Okay, or you can just let them run and go have lunch, etc. But let's say I decided, yeah, this is looking good. That's great. I'm going to do a stop. Okay, and you can see how it was figuring, it's doing a chart. Once it starts flattening out, it's getting better. You can see it's starting to get some white spaces in here for me. Okay. So let's say I'm ready to go. I like this. What I do is just press update drawing. What do I want to send back? The surface, yeah. What do I want to call that? I'm going to call it from GO, GO standing for grading optimization, which is a lot of typing. Okay, what style do I want to apply? That's cool. Do I want the feature lines? I don't have any points, so, and what layer? Not going to worry about that. And finish, and it goes through and it brings that surface in. I get rid of the browser now and this one. And in my prospector here under surfaces, I have that from GO. So let me select that. See, and you can see how it is built around and tried to fill in these areas. Okay, I would need to add some infills in here, I think. That's not an infill. Grading. Yep. That's fine, whichever. Okay, now I don't know if I got that one perfectly good there. That's the original ground. I'm going to turn that off. Well, those are flat, so they shouldn't have contours going through them. Let me make sure they, okay, yeah, so we're picking up elevations, but those are all flat, so they wouldn't have contours. So we'll look in here. Look, it's made us a little site. It's used, we didn't let it iterate all the way. Could have adjusted some of the slopes, etc. But you see it has built those pads for us in this site. And of course, if you wanted earthwork quantities now, that's as easy as going, analyze, volumes dashboard, pull the volumes dashboard to this screen, make a new entry, compare existing with from grading optimization. And that's ended up with about 25,000 yards of fill. But it did nearly 1 million yards of cut and nearly 1 million yards of fill. So 25,000 out of that is not bad. Okay, well, that's what I had to talk to you guys about today. If you have questions, etc., please speak up. No one wants to talk. I'll turn it back to you, Julie or Huli.
Thank you, Tim. Are you done? Right?
Yes, I am.
Okay, so let me share my screen because I wanted to show our upcoming events. So As a reminder, if you want to learn any of these topics in detail, you can always take custom training with Tim or someone else on our team. And on the right hand, we have our events registration link. So you can go here and click on any of these and register if you're interested. And even if you feel or know that you will not make it, you can just register so you can get the on-demand recording. So we'll have next on March 20th from PDFs to projects, how Bluebeam powers AEC success. And then on March 27th, we'll have Revit phases and workflows. And for our clients, subscriber only events, we have our Inventor user group on April 17th. Again, we will be sending the recording of this webinar tomorrow at 11 a.m. Eastern Daytime. So yeah, if there are no further questions, I would like to thank Tim and our attendants for this wonderful presentation and for your time. Thank you so much, Tim, and thank you, everyone.
Okay, you're welcome, Huli. Thank you. We'll
Thank
talk
you.
soon.
Bye-bye.